Hi everyone, today we're going to be looking at the Productivity Open P1AM Industrial Arduino Operators. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. So operators in our productivity blocks program here actually contain a couple of different units. The first one is comparison blocks that will give a true or false. We have concatenate strings, we have bitwise operators, we have string conversion, we have not operators, and we have compound operators. And we're going to look at each one of these, as well as we'll take a look at an example as well of a program or sketch. So the first one is our comparison blocks. So we have 4 of them actually here, and if we actually bring them out onto our work area, you'll notice that they all look very similar, except for the actual handles or tags in here that we can actually place to control either whether this is going to be on or off. So if we actually highlight over it, it'll actually tell you true if a first number equals the second number. So let's just take a look at the number. So let's put a variable in here, and you can see the same shape of the end here. So this is actually a number, and we can compare that to another number. And we have, actually, if we use the down arrow, we have equal to, greater than, less than, greater than or equal to, less than or equal to, or not equal to. Again, this gives us a true or false indication of this operator. Next, what we have here is a round, which is the Boolean. So true if the first value equals the second value. So let's take a look at our variables again, and we will place a Boolean variable into that unit, and you see how nicely it fits right in there, snaps right in. And we can compare whether it's equal to, not equal to. We have an AND operation, so it must be true. Both variables must be true in order for it to go. Or an OR operation, so one or the other has to be true in order for it to be true. Okay, next one we have is a true if the first character is equal to the second character. So these are actually dealing with strings now. So let's take a look at our variables again, and we go down to see where that same handle is. So there's my character. So let's learn a character variable. We can put that in, and you see it goes right in nicely. And in this case, we have equal to or not equal to. So we only have the 2 choices on that particular operator. Next, we have this one, which actually true if the first string is equal to the second string. So again, we're looking at string variables. So let's look at our variables here and go down to where we see our string variable. We can actually put that right in, and you can see how it fits. Again, the shape of what you see here determines what we can use in that operator. And again, we have an equal to or not equal to selection that we can do on this particular operator. Again, that's our comparison operators. So next, what we have is, if we look at under operators, we have this one here, and this particular one, if we highlight it, it'll say concatenate 2 strings. So basically what it does is take these 2 strings and actually put them together or glue them together, so that creates one new variable. So let's take a look at our variables that we can put in here, and we'll take a string constant, we'll plug that in, and we can take a look at our string variable and put that in. So whatever is in our string variable will be then married to a parameter called string constant. So if the string variable had the value high, or the word high, then concatenate them together or glue them together, we'll have high string constant. So that's exactly what that instruction or that operator will do. Next, what we'll do is we'll have bitwise operators. So bitwise operators, they basically look like this. And you can see here that these are bitwise AND operator. So it goes by, again, by the symbol here. You can see we can put integer, we'll put an integer in there. So, or any number that we want into that variable. Now once we have that variable in there, we can then choose bitwise AND or shift left, shift right. Now, let's take a look at that. And if we look at the bitwise and we have operator 1 or operand 1 equals the decimal number 3, which is 0011, and then we have operand 2 equals the decimal value 5, which is binary 0101. If we AND those two binaries together, so that means that both of them must be equal to 1 in order to have a 1 in the output, or what sometimes they call this is a mask in programming. So on this first one here, we have a 1 and a 1, so it's a 1. 1 and 0, it's a 0. 0 and 1 is 0, and 0 and 0 is 0. So our output for 1 and 2 bitwise operation is actually equivalent to 0001 binary, which is actually 1 decimal. Next, what we can do is we can look at this one, which is our OR. If we look at our OR operation, we can have one or the other on a bitwise, so several of these strings together. So if again, operand 1 and operand 2 binary, on operand 1 we'll have 0011 again, which is the decimal value of 3. Operand 2 we'll have 0101, which is the decimal value of 5. When we do 1 or 2, then either one or both of them can be 1 and we will actually have an output. So 1 and 1 is 1. 1 or 0 is still 1. 0 or 1 is still 1, and 0 and 0 is 0. So that equals, or 1 or 2 equals 0111, or the decimal value of 7. So that is our OR bitwise. Then we have our shift left. And on our shift left, if our operand, the first one again is 3, 0011 in binary. And then we have operand 2, which is 0001, which is decimal 1. Then what we want to do is do a 1 shift left by 2. What we'll do is take operand 1. We will actually shift those bits over to the left by a value of operand 2, which is 1. So we shift that over, and what we end up with was 0110, or the decimal equivalent to 6. So that's shifting. It's very, very close to like shift registers that we have in PLCs. And the final one we have in our bitwise operation is shift right. And on the shift right, again, we'll take an example here. We have operand 1, which is 0011, which is the decimal 3. We have operand 2, which again we put as 1, so we're shifting it over by 1. And then so operand 1, shifting right by operand 2, we take 0011, we shift it over this way, and when we do, we lose that 1 out of here, and our result is 0001, which is the decimal value of 1. So that was our bitwise operation. Then what we have is under our operators, we have our NOT operation, and the NOT operation operates with a Boolean expression. And if we had something like not high, that would actually be equal to low. So it's just the opposite effect of what you want on your Boolean. So if you're programming away and you said, no, I really want the reverse logic, we just put a NOT in there and it will actually act as the negative part of that. So operators again, and then we have two string values, and we'll just call up a couple of those. And we have two different ones. We have one string to string value from a number. So we can put any number in here and that will actually create a string for us. We can bring that one back and put actually a variable. And this creates it to a string. Now that string will actually put it in as a decimal numbering system. And then to string on our Boolean. So if it's high or low, it'll actually put a high-low to a string value. Or true or false, it'll put it to a string value. And finally, what we have is our compound operators, and which are right here. And the compound operators, again, very similar to a lot of the ones we've seen before. Right now, it's dealing with the numbers. And if we look down the list, we have an AND. This is logical AND. We have a plus, so we can add. So the first one plus the second one. You can see it changes colors depending on what we want. Minus. We have the multiplication. So this multiplied by this. We have divide. So when we all divide, we want to make sure that that bottom number is not 0. So that's 1. And then we have an OR. So we have the AND bitwise and the OR bitwise that we've discussed before. And then finally what we have is an exclusive OR. And how the exclusive OR works is just like the OR. What it basically says is that if you have two different inputs, or then you turn on the output. So if we have operand 1 as 0011 or decimal 3, and then we have operand 2 as 0101 or decimal 5, then when we 1 exclusive for 2, 1 and 1 is still 0 because they're not different. 1 and 0 is 1. 0 and 1 gives me a 1, and 0 and 0 gives me a 0. So the decimal equivalent is 6 for the exclusive OR. So now let's take a look at a programming example, and we'll do that with our productivity P1AM, productivity open. And on our example, what you'll see is that we'll use a few of these operators within the unit. So first of all, we're going to take a look at our main program here, and we're going to set up our serial port to 115,200. It's going to be serial, 8-bit, no parity, one-stop bit, and it's going to our monitor. So as we did last time, we can see that we can actually use the monitor to get some information. And what we'll do is just ask for a number from the operator and determine whether or not it's a number between 1 and 100. So, and then what we'll do is we have our loop, our main loop. So we're going to check for our CPU switch. If it is on, then we set our CPU light LED high. If it's off, then we set our LED light low. So in other words, it tells whether or not our program is going to be running or not running. And it gives a good indication to the operator when we look at the actual unit whether it's running or not running. So we start that off, and then we do subroutine. So subroutine 1 just sets a Boolean value to low, and then we set an integer to 0. So when we first start out, that's what the variables are, or when the CPU switch is off, we reset them or back to that original state. So you can see that right here. When we have the switch on, we set the LED out high, and then we call subroutine 1. Subroutine 1 is right here. So the first thing we do is look at our Boolean, and we say if it's equal to low, then what we want to do is print a string out, and we say pick a number, or pick a number sample program. That's what we call this sample program that we have here. Then it says please pick a number between 1 and 100. So that will actually print out, and then what we do is take our Boolean and we set that to high. that means that it won't print this again. So it's only going to print it once for us. Now, once we have that set, then what we do is we look for another condition. So we look for if the available port and the number of bytes that are available on the port is greater than 0. So again, here's one of our operators that we've just put in here. And if it is greater than 0, then what we want to do is we want to get the string, and we take the string and we put it into a string variable. So we read those ports and we put that in. Then on the C code, or within productivity blocks, sometimes we don't have the entire list of instructions that we can use within our Arduino. So what we can do is we can actually put lines of C++ code right into our productivity blocks, which allows us to ensure that we have the full capability of what the Arduino instruction set will have. So when we do that, what we want to do is we want to take our integer variable, and what we're going to do is we're going to convert it to a string variable. So that's basically what we're going to do. So we'll take our string variable there and convert it to our integer variable so that we can actually then do some comparisons on it. And that's what the next block will do, our condition. So again, here is our operator. And our operator in this case here is a compound operator. So what we're doing is we're saying if the integer is greater than or equal to 1, and the integer that we've actually inputted is less than or equal to 100, then we can do something. Okay, and what we're going to do is we're going to print the string, and we're going to say your number is, and we're going to concatenate or glue those information together, and then toString, and then our integer variable. So it's going to print that out onto our screen. If it's not within that range, else, then what we do is we print a symbol saying try again. So what we do is we just we would verify this. Then once we've verified it, it would actually come up with our program here and compile it and make sure that everything is the way we should. We have it. Again, productivity blocks makes programming of the Arduino very straightforward, especially on C++ and the syntax that you must use. So it ensures that everything else is going to run well. Then what we do is we can upload that to our actual hardware. And our actual hardware is our productivity P1AM -100. And this is our starter kit, and we are connected through our USB port to program our unit here. And so what we'll do is just download or upload our sketch or our program to the actual unit. So it will do that, and then once we're done with our sketch or our upload, then what we'll do is, and we're done currently right now, upload complete. We'll go to our serial monitor and we can run our program. So right now our switch here is off. Let's turn that on. As soon as I turn it on, again, you'll see our LED light turn on as we thought, or as we programmed in our unit here. And now it's asking me, pick a number, sample program. Please pick a number between 1 and 100. So let's do 23. We'll send that, and when we send it, it'll say your number is 23. If I put another number, or not a number, so I'll say hi, we'll hit send, it will actually say try again. If I turn the switch off, the light goes off, turn it back on, it'll again ask me pick a number. So, and then I can go ahead and do that. Let's try 33. And let's try the actual extreme. So there's 1. And let's see, 100. And then if we can, we'll just do for fun, we'll put in 0. And that should give me try again. which it does, and 101. So above the limits, and we'll see again it says try again, which is exactly what we expected to happen. Now if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time.